Bismillahirrahmanirrahim. Today we are here with a fresh and updated series on the topic of integration. I have intentionally selected a sequence that differ from the order presented in the book, as I believe this arrangement is more convenient and effective for learning integration, and it aims to simplify the learning process, making it easier for students to grasp the concept of integration. Today's topic focus on a special type of integration, the integration by substitution method. This technique simplifies complex integrals by identifying a key clue within the question itself. You can think of it as a special part in the problem. Once we select it for substitution, it transforms the solution process into something much more straightforward and manageable. Today's goal of the lecture is to recognize these clues and effectively apply substitution to make solving integral easier and comfortable. Let's start with the first question, and that is integral e raised to the power sin x into cos x dx. We start our lecture by identifying the special for substitution. In this question, sin x is the special part that simplifies the integral when substituted with any other variable. Let sin x is equal to t, and after differentiating it will become cos x dx is equal to dt. Now let's substitute these two terms in this question, which is equal to I stands for integral, so it will become I is equal to integral e raised to the power t dt, and integral of e raised to the power t is equal to a e raised to the power t plus c, and after that we will back substitute, put the value of t which is equal to sin x, so it will become e raised to the power sin x plus c. Next question is integral tan x into log of secant x dx. Now here log of secant x is the special part, which after selecting we will make the solution for this question more easier. For this, let us take log of secant x is equal to t. After differentiating, it will become 1 over secant x, and derivative of secant x is equal to secant x tan x into dx is equal to dt. Now cancel out secant x with secant x, and after simplification we will get tan x dx is equal to dt. Put this value in original question, which is I is equal to integral log of secant x, and tan x dx log of secant x is equal to t, and uh, tan x dx is equal to dt. Now apply simple integration technique on this part, and it will become t raised to the power 1 plus 1 upon 1 plus 1 plus c, which is again equal to t raised to the power 2 upon 2 plus c. Now back substitute the value in the place of t, and we will get log of secant x raised to the power 2 upon 2 plus c. Similarly, the third question of today's lecture is integral 1 upon 3 tan x plus 1 into cos square x dx. In this question, 3 tan x plus 1 is the special part, and if we take this part is equal to t, it leads our question to the simplicity. Let's start our question by differentiating technique. So differentiating both sides of this part, which is equal to 3, the derivative of tan x is equal to secant square x, and the derivative of 1 is equal to 0. So we are left with only 3 secant square x dx is equal to dt. Put this value in equation number 1, or you can say in original question, and we have I is equal to integral 1 upon 3 tan x plus 1. As you know that 1 over cos square x is equal to secant square x dx. So we replace 3 tan x plus 1 with t and swap secant square x dx with 1 upon 3 dt, and we have, after simplification, 1 upon 3 integral 1 upon t dt. As you know that the derivative of t is present in numerator, so that after integration it will become log of t plus c. Put the value of t, and this technique is known as back substitution. After back substitution, you can get log of 3 tan x plus 1 plus c, constant of integration. And the next question for today's lecture is integral 1 plus 3 cos square x along with square root into sine 2x dx. The special part of this question is 1 plus 3 cos square x, because if we select 1 plus 3 cos square x, we have the derivative of this part present in the question, which after the substitution will become 1 plus 3 cos square x is equal to t. After taking derivative, it will become the derivative of 1 is equal to 0, and 3 cos square x dx will become 2 cos x into minus sin x by using power rule. Dx is equal to dt. After simplification, it will become minus 6 cos x sin x dx dt. We can write it as minus 3 into 2 cos x sin x dx is equal to dt. We will split 6 into 2 parts, 3 and 2, and 2 sin x cos x will become sin 2x minus 3 sin 2x dx. Here is the formula. Here is the formula for 2 sin x cos x is equal to sin 2x. So it will become minus 3 sin 2x dx dt, and we take minus 3 on the right hand side, as we need only sin 2x dx on left hand side, so that it will become sin 2x dx is equal to minus 1 upon 3 dt. Put this value in original question, and we will get I is equal to integral square root t into minus 1 upon 3 dt. Here we apply the power rule technique for integration, so that it will become t raised to the power 1 by 2 plus 1 upon 1 by 2 plus 1 plus c. After simplification, it will become minus 1 upon 3 t raised to the power 3 by 2 upon 3 by 2 plus c. Again, after simplification, it will become minus 2 by 9 t raised to the power 3 by 2 plus c. After back substitution, it will become 1 plus 3 cos square x raised to the power 3 by 2 plus c. Back substitution is the process when we replace substituted term with original value. Next question is integral sine 2x upon 1 plus cos square x. Like previous question, as in previous question we have chosen 1 plus 3 cos square x as substitution. In this question, we have choose 1 plus cos square x as a substitution part. So take 1 plus cos square x is equal to t. After differentiating, it will become the derivative of 1 is equal to 0, and by applying power rule of derivative on this part, we will have 2 cos x, and the derivative of cos x is equal to minus sin x dx is equal to dt. After simplification, it will become minus 2 sin x cos x dx is equal to dt. Now 2 sin x cos x is equal to sin 2x dx, and take the negative sign on right hand side. After substitution this value in original question, we will have I is equal to integral minus dt upon square root t. As t is in denominator, so take this term in numerator, and it will become minus integral minus t raised to the power minus 1 by 2 dt. After applying the technique of power rule of integration, it will become minus t raised to the power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus c. After simplification, it will become minus t raised to the power 1 by 2 upon 1 by 2, which is again equal to minus 2 into square root t plus c. And after back substitution, it will become minus 2 into square root 1 plus cos square x plus c, where c is the constant of integration. Similarly, the next question is integral 1 upon square root x secant square root x into tan square root of x dx. Here we choose square root x is equal to t as substitution. So the derivative of square root x is equal to 1 upon 2 into square root x dx is equal to dt. Take 2 on right hand side, so we have 1 upon square root x dx is equal to 2 dt. Now put the value of t and 1 upon put the value of square root x and 1 upon square root x dx. In original question, we will have I is equal to secant t tan t into 2 dt. As 2 is the constant, so take 2 outside the integral, and we will have integral secant t tan t dt, and the derivative of secant t tan t is equal to secant t plus c, and back substitute the value of t. We will get 2 into secant square root of x plus c. The last question of today's lecture is integral pi raised to the power sin x plus sin x raised to the power pi into cos of x dx. Here sin x is a special part which we will use for substitution. So let sin x is equal to t. The derivative of sin x is cos x dx is equal to dt. So put the value of sin x and cos x dx in original question, and we will have I is equal to pi raised to the power t plus t raised to the power pi into dt. Now separately or individually integrate both parts. So integrate pi of t dt plus integrate t of pi dt. Pi of t, the integral of pi of t will become pi of t upon log of t plus t raised to the power pi plus 1 upon pi plus 1 by using power rule on this part of integration plus constant of integration c. After back substitution, we will get I is equal to pi raised to the power sin x upon log of pi plus sin x raised to the power pi plus 1 upon pi plus 1 plus c, where c is the constant of integration.